between voltage, current, and resistance. Perhaps you've seen this equation. V is equal to I times R. V stands for voltage, I stands for the current, R is resistance. Voltage is measured in the units volts. I, which represents the current, is measured in amps. And R, the resistance, is measured in ohms. Now, you need to know that as the voltage in a circuit increases, the current will increase, provided that the resistance stays the same. If the resistance goes up, the current will go down if the voltage is held constant. So voltage and current, they're proportional to each other, and resistance and current, they're inversely related to each other. Now let's work on a practice problem. Let's say if we have a 12-volt battery connected across a 4-ohm resistor. What is the current flowing in this circuit? Conventional current flows from the positive terminal of the battery to the negative terminal of the battery. This is the opposite direction to electron flow. So to find the current in this circuit, we can use Ohm's law. V is equal to IR. So the voltage is 12. We're looking for the current. The resistance is 4. So we need to solve for the variable I. Let's divide both sides by 4. 12 divided by 4 is 3, so the current is going to be 3 amps. Now let's say if we have 3 resistors connected in series, like this. Let's say this is R1, R2, and R3, and it's connected across a 60-volt battery. Now let's say that R1 has a value of 3 ohms, and R2 is 4 ohms, and R3 is 5 ohms. So what is the current flowing in this circuit? In order to find the current flowing in a circuit where the resistors are connected in series, you need to find the total resistance. And the total resistance is going to be R1 plus R2 plus R3. You just need to add the values of the 3 resistors. So 3 plus 4 plus 5, that's going to give us 12. So the total resistance in a circuit is 12 ohms. Next, you need to calculate the current. So we could use the formula V is equal to IR. So V is 60. That's the voltage across the 3 resistors. We're looking for the current, and then the total resistance is 12. So you can treat this as if it's one big resistor, and you have a 60-volt battery source across a 12-ohm resistor. What is the current in that resistor? So what we need to do is divide both sides by 12 to get the current by itself. 60 divided by 12 is 5. So we have a current of 5 amps flowing in this circuit. Now once we have the current, we can calculate the voltage drop across each resistor. What is the voltage drop across the first resistor? Now in this series circuit, the current that flows in the circuit is the same as the current flowing through R3, R2, and R1. Because there's only one path for the current to flow, it's going to be the same, 5 amps. So to find the voltage across the first resistor, we can use the current that flows through the first resistor times the resistance value of that resistor. So we're using Ohm's law, but in a different way. I1 is going to be the same as I, because that 5 amp current is flowing through each resistor. But R1 is different. R1 is going to be 3. So it's 5 times 3. So we have 15 volts across R1. Now what about across R2? What is the voltage across R2? Well, we could follow the same pattern. So we can say V2 is equal to I2 times R2. So the current is still going to be 5 amps, but this time the resistance is 4 ohms. So 5 times 4, that's going to give us 20. So we have 20 volts across R2. Now across R3, it's going to be V3 is equal to I3 times R3. So I3 is going to be the same as I2 and I1, so that's 5 amps. R3 is 5, so 5 times 5 is 25. So notice that if you add up 15 plus 20 plus 25, it gives you 60. And so the voltage of the battery is equal to the sum of all of the voltage drops across those resistors. And there's something called Kirchhoff's voltage law, which basically states that as you go around a circuit in a loop, the total voltage will be 0. And it makes sense because the battery, it increases the energy of the circuit because it supplies energy to the circuit, so it increases it by 60. The resistors consume energy from the circuit, so they decrease it, thus they have a negative value.